Hello, in this video we're going to look at an interconversion of carboxylic acid derivatives, and specifically we're going to look at how we can turn an acid chloride into an acid anhydride, a carboxylic acid anhydride. And I'm going to show you the reaction, and then we'll look at the mechanism. And I'm going to start with our simplest acid chloride here, so acetyl chloride. Okay, and we're going to react that with acetic acid, shown there, and this is going to form our anhydride, which looks like this. This is a carboxylic acid anhydride, and our byproduct of this reaction is going to be hydrochloric acid. Okay, so let's go over the mechanism of this reaction. And this type of mechanism is called a nucleophilic acyl substitution. And it's going to have, this particular one has 3 steps. And you're going to see that a lot of these interconversions between carboxylic acid derivatives are going to have these same elementary mechanistic steps and pretty much in the same order. Okay, a lot of the ones that I'm showing in this series of lectures on interconversions will have I'll show you what steps they're going to have. I don't want to give away the punchline. Okay, so what we're going to do is, there's got to be some suspense in this video. Okay. All right, so there's our acid chloride, and it's gonna. All right, now this is where things get interesting. Let's not try to make them too interesting. All right. Okay, so we have 2 oxygens in this carboxylic acid, and so we could actually draw this mechanism in 2 different ways. Okay, because this proton can transfer back and forth between those oxygens, so we could potentially have either oxygen be attacking. Doing the attack here. All right. Now, one thing I do want to say is we usually frown in mechanisms of doing an intramolecular proton transfer if that's going to involve 4 atoms, because then you've got a 4-membered cyclic transition state, and that's kind of straight. So let's not. It would probably be like an intermolecular proton transfer would be a more appropriate way of drawing that. But anyways, back to the reaction that we care about right now, which is this nucleophilic acyl substitution. So that's going to start with a nucleophilic addition, okay? And what we get after that is this. Okay. All right, and so we can draw it in that resonance form. We could also draw it in a second resonance form where this lone pair of electrons forms a pi bond here, and we've got another lone pair there. So I'm going to draw that second resonance form because that's how our textbook does this. That's a 3. Oops. That's a plus sign. Okay, we got a plus charge there. All right, so that's our second resonance form. So we've done a nucleophilic addition. We've got a leaving group here, so we can do a nucleophile elimination. Nucleophile elimination. That gets us to here. So we eliminated, and then plus a chloride ion, which I'm going to erase to show. I'm going to erase all this. Okay. Plus we have our chloride ion. And I need that chloride ion now. All right, and then we're going to have one last step in this mechanism. That's going to help us get rid of that plus charge on the oxygen, and that is our chloride ion is going to act as a Bronsted base. We're going to pluck off that proton. We call that a proton transfer. We're transferring a proton from one molecule to another, or from this molecule to an ion in this case. I don't know if I could really call that a molecule. Gets us to our product, which is acetic anhydride plus HCl. All right, and that is going to, and so you can see here we've had a nucleophilic addition followed by a nucleophile elimination followed by a proton transfer. And in this series of videos, you're going to see those three elementary mechanistic steps in that order. And what's going to change from one reaction to another is what's our carboxylic acid derivative that we start with, and what is the nucleophile that attacks that, and sometimes the base will change that we use in the proton transfer step. All right, thanks for watching this video.